Hello and welcome to the video on dividing polynomials. In this video we look at how to substitute into a polynomial, then we'll divide polynomials, then we'll look at the remainder theorem and how to work out what the remainder of a polynomial will be without having to actually divide. But first we'll look at how substitution is presented in polynomial form. Take for example this polynomial p of x, which equals 3x squared plus 7x plus 4. If we want to substitute x equals 1 into it, then p of 1 equals 3 times 1 squared plus 7 times 1 plus 4. I like to use brackets to show my substitution as it reduces confusion when solving long substitutions later on. By simplifying, we get 3 plus 7 plus 4, which is 14. So p of 1 equals 14. Now we can substitute any value in for x. So p of 1 will give us the substitution that will give us an answer of 0. Different values of x will give us different solutions. So for p of a, we simply get 3a squared plus 7a plus 4. We're just replacing the x's with a's. Now I'll show you how to divide a polynomial using long division. We can do long division of a polynomial just like we would with any other integer. The problem is these days it's rarely taught in junior school. It may be worth it at this time looking it up on YouTube or Google how to long divide to give you a basis for this video, but I'm not going to explicitly teach it here. Division of a polynomial can come in a couple of forms. The first looks at a fraction, but really what we're doing is dividing the polynomial x squared plus 7x plus 12 by x plus 3. In the second example, it is written out more clearly as a division. Either way, x cannot equal minus 3. Can you see why? Because while they mean the same thing, if x equaled minus 3, then we would be dividing by 0, which would indeed make the world explode. Now, here's some terminology that is extremely important to learn, and it's used throughout this video. The dividend is the polynomial that we are dividing. The divisor is what we are dividing by. The quotient is the solution we get by completing the long division, and the remainder is what's left over. These words will be used throughout this video, so it's important to learn them and use them quite frequently to get used to them. Let's look at example 3. If we were to factorize the polynomial x squared plus 7x plus 12, we would get x plus 3 and x minus 4. So if we divided the polynomial by either one of those, say x plus 3, we would get x plus 4. Let's see how that works. We'll set up the long division algorithm, and we start by seeing how many times x goes into x squared. That's the first step in the process. It goes into it x times because x times x gives you x squared. It's no coincidence that they are the same, as we will be subtracting in a moment and they will cancel out. Now what we do is we multiply. X times x gives x squared, and we write it directly underneath the squared term. Then we multiply x by 3 and we get 3x. It is important that you line up the x's with each other and the x squareds with each other, because now it's time to subtract. If I was to subtract the blues, x squared minus x squared, it would go away like it never existed. And that's the whole point of subtracting. If we were to subtract the 7x and the 3x, we would get 4x. Our next step is to bring down the 12, and we get 4x plus 12. Now we repeat that process. We're going to see how many times x goes into 4x, which is 4. Now we multiply that 4 by each term that we are dividing by. So 4 times x gives us 4x, and we write that underneath the 4x, and 4 times 3 gives us 12. And again, we subtract. What we notice is we get a remainder of 0. This means that x plus 3 divides evenly into our polynomial. So we have x squared plus 7x plus 12 divided by x plus 3 is going to equal x plus 4 with no remainder. This can also be written as the polynomial x squared plus 7x plus 12 equals the multiplication of x plus 3 and x plus 4, plus a 0 remainder. This is how all divisions can be written. The dividend equals the divisor multiplied by the quotient plus the remainder. Those words will be used quite often in this video. Let me show you a number example to give you an idea of exactly what that means. Let's say we wanted to do 123 divided by 10. We would get 12 with a remainder of 3. This can be written as 123 equals 10 multiplied by 12, which gives us 120, plus 3, which is the remainder. And this is how we wrote our final answer. Let's try another example. If p of x equals 3x cubed minus 7x squared plus 2x plus 4, we're asked to divide p of x by x minus 3. I've already set up my algorithm, so let's get started. First step is to ignore the minus 3 for a moment and work out how many times x goes into 3x cubed. Because 3x times x gives us 3x cubed, we put the 3x squared above the minus 7x squared. Now we multiply 3x squared by x, and we get 3x cubed. We multiply 3x squared by minus 3, and we get minus 9x squared. Now it's time to subtract. Now when we subtract the 3x cubes, they go away. Now here's an important tip. When we subtract minus 7x squared minus 9x squared, it becomes an addition. So that subtraction of the x squareds becomes 2x squared. We then bring down the next term, plus 2x, and we repeat the process. We ask ourselves how many times x goes into 2x squared, and that's 2x times, and that goes above the x. Now we multiply that 2x by x, which again gives us 2x squared, and then 2x by minus 3 gives us minus 6. Again, we subtract. The x squareds go away, and 2x minus 6x becomes a plus, which becomes 8x. We bring down the next term, and we repeat the process. We do this until there are no terms left over. So, x into 8x goes 8 times. We multiply 8 by x, which gives us 8x, and that's the whole point. We multiply 8 by minus 3, and we get minus 24. Now we subtract for the last time. The x's go away, and 4 minus 24 gives us 28. This is going to be our remainder. So our polynomial 3x cubed minus 7x squared plus 2x plus 4, when divided by x minus 3, will give us 3x squared plus 2x plus 8 plus 28 out of our remainder of x minus 3. Let me give you an example with numbers. Say we had 9 divided by 4. 4 goes into 9 2 times with a remainder of 1. But we don't write remainder 1. What we write is 1 out of 4. And this is how our remainder is written in our answer. 28 over what we divided by, the x minus 3. Again, we can also write this as a product, as our multiplication. And this is important that we can do this because later on with the remainder theorem, this is essential. Let's look at how we can write this in another way. Let's say we have 3x cubed minus 7x squared plus 2x plus 4. It gives us our answer, which is a product, plus the remainder of 28. Now, how could we possibly work out what the remainder is without having to actually do the division? Well, if we could possibly make x minus 3 a 0, then what would happen is we would be multiplying and we would get answer of 0 because all of that would be 0. Anything you multiply by 0 gives you 0. So that would leave us only with the remainder of 0. Let me show you how we do this. So let's say x minus 3 equals 0. That means that x is going to equal 3. This is going to give us a little hint on the remainder theorem later on. So by substituting x equals 3 into our polynomial, we get, well, that substitution. And by simplifying and solving, we get 28. Our remainder. It's magic. At this point, I notice that the video is getting a little long. So I'm going to split this up into 2 parts. Please make sure that you check out the second video, which will give us some more examples and just let us know what the remainder theorem is about. Thanks for listening.